Hey, what's going on, guys? So, this video is going to deal with everyone's favorite thing when it comes to graphing, which is slope. Now, a lot of kids hate it. I'm not really sure why, because it's such a very easy concept to understand. So, slope is just a constant rate of change, right? That's not it. It's a constant rate of change. For instance, we see it a lot in life in the outside world. So, when we're talking about slope, one of the things that I always think of, because I've worked for so long since I was young, is that when you're working, you get an hourly rate. So, for instance, let's say you're making $8 an hour. Every hour you work, you make $8 more. Now, that's a definition, or that's a good, solid example of slope, because for every hour you work, it goes up constantly. So, if you look, let's say here's hours. Right, and then here's your money. So if you work 0 hours, you have $0. If you work 1 hour, you have $8. If you work 2 hours, you have $16. If you work 3 hours, you have $24. Then we can guess that if you work 12 hours, well, let's see. The increase here is 8, because we said that's the money you're making per hour, and like I said, that's your slope. So really, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So really, if you're given your number of hours worked and you know how much money you're making, or your slope, 8 times 12 is 96. So if you work 12 hours, you're going to make $96. Okay, that's a very, very basic, solid definition of slope. All right. So, let's look here. Let's see if I can give you a graphical representation of it. So, let's look at a graph, right? And we're just going to primarily look in this first quadrant. Okay. So, oops. If you look at this line, I'm just going to tell you that this blue line right here has a slope of 1. All right. So, for blue, m is equal to 1. All right, because if we look here, there's one box. Let's see, there's one box underneath it holding it up. Let's just think of it for that aspect. So there's one box holding it up, so it's a slope of 1. Now, I'm going to graph a red line that's going to have a slope of 2. Oops. All right. So, now again, I'm going to draw another line that's going to hold it up, or another box that's going to hold it up. So now if we look here, for our red line, we have 2 boxes holding it up. So for the blue line, it's the slope is 2. All right, and I'm going to draw one more line. Let's make this one a little pink. So this line, oops, I graphed that incorrectly. This line is going to have a slope of 3. All right, and if we look here, it's supposed to go through this point right here. This line is now going to have 1, 2, 3 boxes holding it up, you could say. All right, so basically, as you look at each of these lines, the blue, red, and pink, as the slope increases, which is there's a higher rate of change, meaning for every time we go to the right once, we're going up more. So for the blue, if you noticed, we went 1 to the right, we went up 1. We went 1 to the right, we went up 1. We went 1 to the right, we went up 1. We went 1 to the right, we went up 1. For the red, we went 1 to the right, up 2, 1 to the right, up 2, 1 to the right, up 2. And for the pink, we went 1 to the right, up 3, 1 to the right, up 3, 1 to the right, up 3, 1 to the right, up 3. So, as you can see that the larger the slope is, okay, the higher the number, the faster it's increasing, because the rate of change is that much faster. And if we go back to our money example, if I'm making $10 an hour, you're making $15 an hour, over the long run, you're going to make a lot more money than I am. Your line is going to get higher a lot faster because your slope is, or your hourly wage is $5 more than me. All right. But that brings us into our next idea, which is the graphical representation of slope. Okay. So I'm going to erase these and we're going to talk about it again. So let me just draw a line here. All right. Let's put it on 0, 0. Oops. And let's bring it like right there. All right, that works. All right, so that's our line. And again, the line's going to extend the other way, but I'm just going to work on the first quadrant just to make it look neat, nicer and make it more neat. All right, so again, let's start here where we were starting before at our origin, the point 0, 0. Let's find one of our first points. So we're going to go over 1, 2, 3, 4. So 4. Okay. No, that's x. Again, what I meant to say is we're going 4 in the x direction, since this is our x-axis. And this is our y-axis, okay? If we remember, the x-axis is your horizontal axis, the y-axis is your vertical axis. Okay? So x-axis, y-axis. So we're going a change in 4 of x. Now, if we look at our y change, we're going to go up 1, 2, 3, 4, 5. All right? So here it's going to be up 5. So our change in the y is 5. All right? So when we talk about slope, the way that we can define it graphically is the change of y over the change in x. Okay? So the slope of this line, or which we're going to denote with m, is really 5 over 4. For every 4 we go to the right, we're going to go up 5. Because as our slope increases, as our graph increases with respect to the x-axis, it's 4. With respect to the y-axis, it's 5. So we're going to the right 4, going up 5, and that's how you graph your line. Now, the good thing about finding lines, or points on a line, is that it doesn't matter really where your points are. So, for instance, let me draw another line. So, alright, so we have this purple line. Alright, no matter what 2 points we pick, whether it's a point all the way down here and a point all the way up here, or if we pick a point here and a point here, no matter what, your slope is always going to be the same. All right? So what I'm going to do, just to make it easier, is I'm just going to start at the origin again, since our line goes to the origin, and I'm going to pick this point right here. All right? So if we look here, our change in x is 2, and then to get from here up to our point, we have to go up 3, so our change in y is 3. That means that our slope for this line is going to be 3/2. All right? Pretty simple, pretty straightforward. Again, your slope is just, you count how many the change in x is, how many the change in y is. And hopefully that one's pretty easy. We'll do another one, except this time our line, instead of increasing, like the last 2 lines have been doing, this line I'm going to have it decreasing. And it's not going to go through our origin. Alright? Oops, don't want to do that. Alright, I'll restart that. Alright, make that there. Alright, and that looks about good. Alright, so again, now let's count the change in x. So again, the x, we're going to go 1, 2, 3, 4. So that's a change in 4. All right, and then our y, we're going to go down 1, 2, 3. So our change in y is going to be the number 3. So again, our m, the change in y is 3. The change in x is 4. Now, the only difference is if you notice this slope, if we were going from left to right, we'd actually be falling down, we'd be sliding. So we'd be decreasing. So the one thing we know about our slope is it's actually negative. All right, the slope of a decreasing line is always negative. Whereas if you look at our last 2, going from left to right, we're climbing up, so our slope is positive. And again, we're climbing up, so our slope is positive. All right. This brings us to our next definition of slope. Well, it's not really definition, it's more of the equation, all right? And it's m equals y2 minus y1 over x2 minus x1. And that's if we're given 2 points where the first point is x1, comma, y1, x2, comma, y2. All right. So just a quick example. If we're given 2 coordinates, let's say it is -3, comma, 4 and 7, comma, 6. All right. Let's just see how we can find this. So the first thing you could do is you could actually graph both these points on a graph, which I'll do that now. So let's just scroll down. All right. Let's see. So -3, 4. I'm going to go to -3, 1, 2, 3. Go up to 4. 1, 2, 3, 4. And that's, oops, I want that to be red. All right, and that point is right there. So that's -3, comma, 4. Next point, we're going to go to 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And we're going to go up to 7, comma, 6. All right. Now, to find our change in x, we're just going to count left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a distance of 10. Then we're going to count up. We're going to go 1, 2. Okay. So our m for this one, our change in x is 10. Our change in y is 2, which that's going to simplify down to 1/5. Okay, so for every 5 we're going left or right, we're going up or down 1. All right, so this is the graphical way to find slope. The next thing we can do is we can do a algebraic way of finding the slope, which is the equation we had up there, up top. So let's scroll back up. All right, so we're going to have x2, let's say this is number 2, the coordinate number 2, and this could be number 1. All right, so again, our m, or our equation, is going to be 6 minus 4 over 7 minus -3. All right, so 6 minus 4 is going to give us 2. 7 minus the -3 is actually a super plus, so it's really 7 plus 3, which is 10. Or that also simplifies down to 1/5. Again, the same thing we got when we graphed our slope, and we got it graphically. So this is another way you can do it. So again, our slope is 1/5. Again, as we change 5 in the x direction, we change 1 in the y direction. Now, the third way you could do this, and this is just a different way of writing the slope equation. I call it the coordinate method. So some of my students like this better. Again, like I said, no matter how you do it, you're going to get the right answer as long as you do it mathematically correct. So what you do for this one is you take one coordinate, 7 over 6. You put your next coordinate underneath it. Again, order does not matter because the signs are going to cancel each other out. And what you're going to do is you're just going to subtract, you're just going to subtract these 2 points. And what you're going to be left with is your change of coordinates. Okay? So if you look here, 6 minus 4 is 2. 7 minus a -3, again, like I said, is going to be a super plus since we're subtracting a negative, and that's going to be 10. So here, if we look here, we know that slope is change in y over change in x. The change of y is 2. The change of x is 10. 2 over 10 goes to 1/5, which is our slope, which again is the same slope we found the last 2 times we did this problem. So there you go. That's how you find the slope of a line through 2 points. Hopefully you found this video useful. The next video I'm going to come up with is talking about intercepts, x and y intercepts, and how they interchange, and then how that goes into graphing. So hope you guys found this useful. If you have questions, email me, and have a good football Sunday.